Ptolemy, was one of the greatest scientists ever and most influential scientists. And his most important work is, of course, Al-Majest, which is Arabic for the greatest. And in it, he sort of codifies the geocentric universe. And this Earth-centered universe prevailed for centuries until Copernicus and Galileo turned that around. But what I want to call your attention to are notes that he penned in the margin of the manuscript of his work. Let me remind you that back then, you would look up at the night sky and the planets would move against the background stars. They would wander, because that's what the word means in Greek, is wanderer. And there were 7 of these objects, the sun and moon included. And they would just kind of move. They'd go to the left, and then they'd slow down and pause, and then they'd back up, and then they'd reverse again. And this was a mystery, complete mystery. And, of course, the heavens were not Earth. And so the fact that you didn't really understand what was going up there was kind of okay and expected, because that was the work of the gods. And we, being mortal down here on Earth, if you can't understand it, don't lose sleep over that fact. You perhaps never will. Now, Ptolemy had sort of the best going explanation anyone had put forth with the epicycles and the like. But nonetheless, this is the boundary between what is known and unknown about how the machinery of the universe works, and he pens these words, which for me are one of the most beautiful and poetic references to the state of one's knowledge ever written. I know that I am mortal by nature and ephemeral, but when I trace at my pleasure the windings to and fro of the heavenly bodies, I no longer touch earth with my feet. I stand in the presence of Zeus himself and take my fill of ambrosia. And so therein is this emotional, he's got this sort of religious feeling at the limits of his knowledge. And this is a trend that will continue for thousands of years to follow this. At least 2,000 years to follow this. And you don't have, and this whole notion of intelligent design, this is intelligent design. This quote that I just read to you is Ptolemy invoking intelligent design. No, he's not trying to get that into the classroom. He's not, there's the politics of intelligent design in modern time. Who else do we have? Oh, Galileo, interesting case. Galileo was kind of an exception to this. We all know he was a deeply religious man, and a lot of the trouble he got into was because he was just kind of obnoxious, all right? He could have made nice with the Pope, and he did not. And, of course, I'm paraphrasing. I mean, that's the Reader's Digest version of what happened over that period. But let me share with you some lines that he wrote to Christina, who was the Grand Duchess of Tuscany. Some of these quotes you've heard before, but I think they're worth taking to heart. The Bible tells you how to go to heaven and not how the heavens go. That's one of the famous quotes attributed to Galileo. Another one is, I do not feel obliged to believe that the same God who has endowed us with senses, reason, and intellect has intended us to forego their use. And so he was kind of I see him as one of the first to say, all right, if religion if there's any point and purpose to it, it's not to serve as a science textbook. Okay, this gentleman, I can back up here, Sir Isaac Newton. Now, I don't know what you know of Isaac Newton, but everything I've read of his tells me that there's no greater genius to ever walk the surface of this earth. I'm I don't know if you've ever felt that about anybody. I didn't feel that about anybody. But you just read what this man wrote, okay, line by line by line. This guy was plugged into the machinery of the universe. I think he's unimpeachably brilliant, unimpeachably brilliant. And let me read again what we heard from Mike Shermer earlier in Isaac Newton's writings. By the way, in his Principia, here's the page 0 of Principia. In it, he discovers the laws of motion, F equals ma, discover the laws of gravity. It's all there. And he did this all before he turned 26. And in this, when he talks about motion, there's no reference to God. When he talks about his two-body force that he deduced, this universal law of gravitation, there is no mention of God. It's just not anywhere there because he understood it. He was on top of it. He was there. Even though the understanding of the motions of the planets before he came along was given unto God because nobody understood it. Or nobody understood well enough to really believe that they had a full predictive handle on it in the way the universal law of gravitation supplied. And so what you have is Isaac Newton abandoning reference to God until he realizes that if all you do is calculate the two-body problem, here we have like the moon and Earth. Yes, he's got that calculated. Now you have the sun and the Earth. You got that. But wait a minute. Now the Earth and the moon go around the sun, and sometimes we're close to Mars and sometimes we're not. And when it comes near Mars, there's a tug that's stronger there than in any other part in the orbit. And then it comes over here, and then Jupiter tugs. And it's all these mini tugs. And so he's got to do this two-body problem for Earth, the moon, Earth and the sun, Earth, moon, and Mars, Earth, moon, Mars, and Jupiter, and it becomes a rapidly complex problem. And he realizes that, in fact, applying this simple sort of approach to calculating the stability of the solar system, he finds he can't stabilize the solar system. He can't account for how we have stayed this way for as long as what was possibly necessary from the beginning of the universe. And so what does he say? He's at his limits. He's at his limits. And so you read but God is nowhere until you get to the general Sholem. And then he says the 6 primary planets. Back then there were 6 planets, okay? Now there's 8, in case you haven't been keeping track. Even if you thought there were 9, there are now 8. The 6 primary planets are revolved about the sun in circles concentric with the sun, and with motions directed towards the same parts and almost in the same plane. He's got the whole picture now, and he's trying to sort of account for that. But he can't just simply doing two-body calculations, certainly not without a computer or without a new kind of mathematics. He says, but it is not to be conceived. But is it not to be conceived that mere mechanical causes could give birth to so many regular motions? This most beautiful system of the sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being. This is Isaac Newton invoking intelligent design at the limits of his knowledge. And I want to put on the table the fact that you have school systems wanting to put intelligent design into the classroom, but you also have the most brilliant people who ever walked this earth doing the same thing. And so it's a deeper challenge than simply educating the public. It's deeper than, as you know, by the books written by our scientific colleagues that do take these deeply resonant and charitable positions towards their religious beliefs. Maybe the real question here, let me back up for a moment. You know, we've all seen the data. 40%, there's 90% of the West or the American public believes in a personal God that responds to their prayers. And then you ask, well, what is that percentage for scientists? Averaged over disciplines, it's about 40%. And then you say, how about the elite scientists, members of the National Academy of Sciences? An article on those data recently in Nature, it said 85% of the National Academy reject a personal God. And then they compare it to 90% of the public. You know, that's not the story there. They missed the story. What that article should have said is, how come this number isn't 0? That's the story. Okay? So my esteemed colleague here, Professor Krauss here says all we have to do is make a scientifically literate public. Well, when you do, how can they do better than the scientists themselves in their percentages of who is religious and who isn't? That's kind of unrealistic, I think. So there's something else going on that nobody seems to be talking about. That as you become more scientific, yes, the religiosity drops off, but it asymptotes. It asymptotes not at 0. It asymptotes at some other level, so they should be the subject of everybody's investigation, not the public. I'm telling you. So it's not 85% reject, it's that 15% of the most brilliant minds the nation has accepts it. And that's something that we can't just sweep under the rug. Otherwise, we're being disingenuous to the efforts here. And I know I'm standing between you and lunch here, so let me try to go quickly. If you don't think, I think Newton is one of the most brilliant, like the most brilliant ever to sort of walk the earth. And I'm not alone in feeling this. This is his statue in Trinity Church in Cambridge, and he's through the open doorway there. And so you get close to the statue. He's without his curls here. I was deeply upset by that. I thought he was like really trendy with his long hair. But apparently that was probably just a wig at all times. You look at the base of the statue, loosely translated, of the genus of all who have ever been human, there is no greater intellect than this man. And so I'm not alone in this sentiment. And this man wrote those words. So, but let's move on, because there's more to talk about here. We don't have to stop at Newton. Let's go to Christian Huygens. All right? Brilliant scientist. I mean, he was great at chemistry, biology, physics, math, a Dutch scientist. And he died the year that this work was published, one of my favorite works of science writing. And it's Cosmotheros, which is an exploration on the likelihood of there being life on the known planets, using the available knowledge of the day. So, for example, they knew that, by the way, Huygens was the first to identify Saturn's ring as a ring. If I got that right, Carolyn, is that correct? Oh, no, I thought he was the first to calculate that it would be a ring. Then Huygens would be the first to observe it. Okay. We have Madam Saturn here in the room, in case you don't know. Okay. My colleague Carolyn Porco, who we'll be hearing from later, I've just been told. But anyhow, so Huygens, brilliant fellow, and one of the probes on the Cassini spacecraft was called Huygens, a European probe that descended to the surface of Titan. And so he's an important figure in the history of science. So what does he say in his writings? Well, you look at the year 1696. Gravity was well known. Laws of motion were well known. Newton was quite influential well before the turn of the century there. And so when he talks about the orbits of the planets, it's done. Talks about the moons of Jupiter, done. Talks about the new rings around Saturn, done. It's all fine. But when he talks about biology and life, something that's not well understood then or today, boom, there goes his references to God. But references to God were nowhere else in those writings. Nowhere else. He says, I suppose nobody would deny but that there's somewhat more of contrivance, somewhat more of miracle in the production and growth of plants and animals than in lifeless heaps of inanimate bodies. For the finger of God and the wisdom of divine providence is in them, much more clearly manifested than in the other. He doesn't say that about the orbits. We're done with the orbits, as Mike Shermer had noted. We're done. He's in a place where nobody really has the answer. So he invokes, this is intelligent design once again. Pure out, flattened. All right? So Laplace, Pierre Simon de Laplace, at the end of the 18th century, wrote a 5-volume tome on celestial mechanics. A brilliant piece of work. It's there. It weighs a lot on the shelf. And what it does is it takes Newton's laws of gravity and brings them into a full expression with the hammer of calculus. Okay? He brings all the armament of mathematics to bear on the laws of physics that were put forth by Isaac Newton. Isaac Newton only touched on them. They were not fully developed. And in this work, he demonstrates, he further develops something that had been percolating in the mathematical community, but he develops, and one might even say perfects, a branch of math we would call perturbation theory, where instead of pulling your hair out saying, well, how do you calculate this pair of forces and this pair and this pair, and all the equations go to hell, in perturbation theory, it allows you to systematically and reliably calculate the effect of a small tug in the presence, a series of small tugs in the presence of singular big tugs. And that's kind of what's going on in most of the solar system. And when you do that, and you do that properly, you can demonstrate, notwithstanding effects of chaos, which have other timescales related to them, you can demonstrate that, in fact, the solar system was stable beyond the predictions of Isaac Newton. So, he figures this out, does not invoke God, because he figured it out. And in a story that may be apocryphal, but I see more in support of it than against it, this time coincides, of course, with the era of Napoleon, Napoleon being French, and Laplace being French. No translation necessary. Napoleon, if you visited his library, it's not just sort of books of world history and battles. It's engineering books. It's physics books. This man wanted to know where his cannonballs would land, all right? He was much more than just sort of a lucky general. He was into the physics, the engineering, and the material science of war. And so he immediately summoned up the 5-volume production of Laplace, read it through, cover to cover, called in Laplace, and said, "Sir," I have the exact quote here. Hang on. Napoleon asked him what role God played in the construction and regulation of the heavens. This is kind of like, that's what Newton would ask, right? Laplace replies, "Sir, I had no need for that hypothesis." And so what concerns me now is, even if you're as brilliant as Newton, you reach a point where you start basking in the majesty of God, and then your discovery stops. It just stops. You're kind of no good anymore for advancing that frontier, waiting for somebody else to come behind you who doesn't have God on the brain, and who says, "That's a really cool problem, I want to solve it." They come in and solve it. But look at the time delay. This was a 100-year time delay. And the math that's in perturbation theory is like crumbs for Newton. He could have come up with that. The guy invented calculus just on a dare, practically. When someone asked him, Ike, how come planets orbit in ellipses and not some other shape? And he couldn't answer that. He goes home for 2 months, comes back, out comes integral differential calculus, because he needed that to answer that question. And so this is the kind of mind we were dealing with Newton. He could have gone there, but he didn't. He didn't. His religiosity stopped him. And so we're left with the realization, of course, that intelligent design, while real in the history of science, while real in the presence of sort of philosophical drivers, is nonetheless a philosophy of ignorance. And so, regardless of what our political agenda is, all you have to say is, science is a philosophy of discovery, intelligent design is a philosophy of ignorance. That's all. I don't need to see have you discovered anything lately? If not, get out of the science classroom. But I'm not going to say, don't teach this, because it's real. It happened. So I don't want people to sweep it under the rug, because if you do, you're neglecting something fundamental that's going on in people's minds when they confront things they don't understand. And it happens to the greatest of the minds, as it happens to everyone else, many, if not most other people in the public.